I have drawn up here the basic schematic diagram of what we call an AC coupled amplifier. One of the reasons why you might have this, particularly in audio system, is because the DC voltages of each succeeding amp and each preamp and each succeeding amp might cause the circuit to not function right because of extraneous voltages getting into them. By putting capacitors in series with the input and the output lines, it keeps the DC from previous circuits and circuits out here from getting into the amplifier circuit and causing it to not function properly. In this particular case, we're using the conventional inverting terminal type of feedback control, RF over this RN, which is going to establish the gain for the amplifier. If we take a look at this part down here on the non-inverting terminal, what this is doing is we're taking the voltage from the positive part of the power supply and putting a voltage divider here so that 50% of that appears here at the non-inverting input. The purpose of that is what's known as a quiescent level. So with no signal applied, the DC sits right here at the quiescent level of voltage. In the case if I had 12 volts applied to this, approximately 6 volts would be that terminal. What that allows us to do is when I apply AC, is it takes it very close, not exactly down to 0, right here, but pretty close to it, and it allows us to go up on the positive part of the signal and get pretty close to 12 volts, but not completely. And that's because of some of the voltage drop occurring in the output of the op amp. But the calculations are pretty close for using these to estimate the amount of gain and what the output signal would be. And definitely keep in mind though that this non-inverting terminal is being derived from a voltage divider at this point.